And welcome back to another video in the series. This is 3.5, so this is a lab where we explore some of the advanced features of EIGRP using classic config. So the topology is basically that used in the last series of presentations, and what we're going to do is just run a few little items on. So if we do a shoe IP route, you'll see that I've got some routes already being populated via the routing protocol. Now, haven't finished configuring router 3, so let's start off with adding some loopback interfaces so that we can use those routes for route summarization and finish off our EIGRP configuration for the topology. So let's get underway with adding our loopback interfaces, and we're going to use IP addresses of the 192.168.1 variety, and we're going to add 3 of these. So loopback 2, which will be the 2 network, and then loopback 3, which will be the 192.3 network. So that gives us a few routes to add. Now, to configure EIGRP autonomous system number 10, and then add the networks. So network 10, and we can just put this as class, which will include all the routes from the 10 network, and we have a 172 network in there, 172.16 something something. So we'll match the first 2 octets and don't care about the last 2. That'll be our link to router 2, and we have a neighborship adjacency forming now because we've activated the routing protocol on that link. And now for our 192.168 networks, again we'll just match the first 2 and wildcard the last. Alright, so if we do a show IP route, we should have our directly connected networks all appearing. And then, hopefully, if it's all working correctly, if we bounce back across the router 1 and rinse and repeat, we should have the 192.168s appearing, and we've got the 3.100 there, and I've forgotten to do one thing because the 3.200's not there. You know what I've done? I've forgotten to do. So if we do a show IP interface brief, yes, I have. Okay, when I originally set up this topology, I configured the wrong interface. Gigabit 2 should be the 200, not 3. So let's do a quick change. Config T and go to interface G03, no IP address, and shut it down. Then go to 02, 02, and put in an IP address of 10.3.200.1, and it was a /24, and activate that. And the interface is now up. So if we wait a second and jump back over here, we now have the 3 to 100 visible. Okay, so that's our first task. Now, so topology is running. We've got the routes appearing in the routing table. So let's verify our timers. Show IP EIGRP interfaces detail. Now if you hit enter now, you'll get all your interfaces coming up. You can specify which interface you want to look at in detail. So here I've specified gigabit Ethernet 01, and my interval's 5 and holds 15, which is 3 times. Now, how do I change that? Well, it's very easy. We go into config, go to the interface itself, and configure IP hello to interval, specify the protocol that we want it to run on, which autonomous system we're using, and the new time in seconds. So we'll double it to 10. Helps if I GRP. Helps if I type correctly, doesn't it, folks? Okay, the other timer is the hold. So hold time again, which protocol, autonomous system, and the new time in seconds. Alright, we end that. And if we scroll up and do the show IP EIGRP interfaces again, we now see the hello interval and hold timer have been adjusted for this interface. And if we look at interface 2, it's still on the original timers. Now, if you're going to adjust timers, I would suggest you adjust them on all the appropriate interfaces. So if we did the one facing router 2, which we did with the original interface that we did, we changed the timer there. We should change the timer there so that the actual dead time is the same across both ends of the link. But as this is just for demonstration purposes, I'll just keep it there, as I'll try to keep the length of this video down a bit. So that's our timers done. The other item we looked at was route summarization as part of the advanced features. So what we want to do is to do route summarization on those 192 networks. So on router 3, if we remember, we did those loopback interfaces of 192, so let's do a show IP interface brief, and there's our loopback interfaces. So we want to summarize those addresses. So when you're doing route summarization, you look for the common bits. So first 2 octets are common. There's differences from the 3rd octet. So expanded out the binary, it's going to be 7 zeros and a 1, 6 zeros, 1 0, and 6 zeros, 1 1. So what's common there is the 6 zeros in the 3rd octet. So 8 and 8, 16, and 6 is 22. And if I remember my subnetting correctly, that would mean that the 3rd octet would be 252. So let's go to the interface facing router 2, on which again is G01, and we want to put an IP summary address in for EIGRP Autonomous System 10, and we want to add 192.168.0.0 with the new mask 252.0. Now that should cause a change. So let's exit out of D, and we should have seen a dual algorithm change. So let's pop over to router 2. Show IP route. Did I get the wrong interface facing router 2? Let's go back to router 3 where those interfaces are. Show IP interface brief. Can't do it while I'm in config. That's zero. I've put the summary address on the wrong interface, folks. There's a bit of troubleshooting for you. And if we highlight, that's nasty. We only want to highlight the summary address. There we go. So if we go to interface G01 and do a no summary, and then go to our correct interface of G00 and paste in the summary. There's our dual exchange. Thank you. That's what I was expecting. You gotta love it when a plan comes together. So as you can see, troubleshooting is part and parcel of config. So if we now look at our IP route on router 2, we've only got one entry for the 192.168 network, and that will then propagate through to the rest of the topology. So instead of 3 entries, we now have 1. This saves time and resources within the network and enables us to have smaller routing tables. Now, you're going, what's the point? On a small network, there's not much point to it, but when you start dealing with large enterprise networks with lots of entries, it is advisable to summarize and condense your core routing tables to make them more efficient, because for every entry in a table, it means it's one more line that you need to process every time you do a search for a route. So by having your network summarized, you can make your routing lookups more efficient. Okay, the next section that we should cover is the stub. So if you remember in the theory presentations, we made router to a stub, and we saw, as it's a central hub point, the damage that was caused, or the chaos. So what you would class as stubs would actually be router 1 and 3 in a real topology, because there's only one way in and out for these, so they're not advertising routes down to these other networks. So these are actually stub routers. So in a live scenario, these would be more relevant to being advertised and set up as a stub. But to show the potential chaos that can occur when you put this configuration on a device that is not really a stub network, where you can see what will change. So you can see here what networks we've got and which ones will change. So to configure it, we just go into router EIGRP 10, and it's not a very hard command. It's really, I've lost my notes. Hang on a sec. Alright, now I remember what I was trying to get across. It's a very simple command to implement, which, you know, that's it, done. But the effect it has on its neighbours is quite large. So I'll just Control Z that there to exit out. So router 2's routing table, no change, right? It sees the 100s, the 300s, and all the 172s and the 168s. But what has changed is the routing tables of its neighbours. So now we have a much smaller network. Notice there's no 10.3 networks, and all of our 192 networks have disappeared as well. And if you look through the list here compared to here, you'll see we're missing a 172.16 network, which is not in here anymore. which will have been the consequence of this stub behavior. So to recap, our stub network will receive updates from its neighbors, but it will not forward other updates. Okay, so it'll only forward routes that are directly connected to router 2 to its neighbors. So if we look down in our little scenario here, 172, 34, 23, and 12 are directly connected to R2, and they're the only routes that will forward. So we look in at R4, its routing table's not going to be very interesting whatsoever. It has the 12, 23 and the directly connected 34. It doesn't have any of the 10 networks or the 192 networks because router 2 is not forwarding those updates to router 4. So as the point was made in the theory, having it in the wrong place can adversely affect your outcomes. Now, the workaround for this, if you remember, was a solution in named configuration. So that under the named configuration, we could use the Stubs site subset commands, which would enable us to control which updates could be shared within the site, even though it's a stub network. That command set is not available under classic configuration. So I would encourage you to explore the command options in name mode, and in the next video, as this is over 20 minutes already, we'll go over some of the more advanced features covered in the theory, but I will use the named configuration using this topology, but we'll concentrate on the other features that we need to cover. Alright, that's it for me. Until next time, I hope you have a good day, and bye for now.